You watch software engineers and machine learning experts at work as they have been on this project. How far along the path to artificial intelligence
do you think we are?
The primitive forms of artificial intelligence we already have proved very useful. But I think the development of full artificial intelligence could spell the end of the human race.
How many years ago was 1827? It's today. 2 hours and 15 minutes down this road. 30 minutes slower if you go down this road. Please answer the question provided. This process is used to prevent automated processes. What isn't quat? Cat and quat. Spelled backwards. Semicolon talc and tack. Talc and. The answer you entered is not correct. Failed to print document. Printing is not supported on this printer. Member since 2561. Who created Kirby? Kirby creator. Masahiro Sakurai. Open App Store. It doesn't look like you have an app named App Store. If you'd like, I can help you look for it on the App Store. What is the weather today? Looks pleasant outside. Minus 999 degrees Fahrenheit. Partly cloudy. You have minus 68 days to update the app. What is the cost of a train ticket from Sydney to Brisbane? The answer is about 28.8 quadrillion kilometer US dollars squared. Windows did not shut down successfully. If -1 messages. Person. Laptop. Dog. Project Cars. Not responding. Project Cars is not responding. Windows is checking for a solution to the problem. Windows problem reporting is not responding. Windows is checking for a solution to the problem.
We recently moved. And when you move in Germany, you have to do a lot of bureaucratic things. For example, telling someone that you live in a new place. Wrong remote. Which kind of fits to the theme. What you do is more or less you enter your address into this form here. And I noticed that my address was not there. My street was not, Düsseldorf wasn't there. Okay, so I tried the zip code, tried the city. No chance. So the solution is you have to start with the zip code on the right side. Otherwise it doesn't work. And when I saw that, I thought we have to speak about broken things. We have to speak about brokenness in software. Like, of course, it's an exaggeration. Not everything is broken, right? At least the political system in America and England still works. What I'm talking about mostly is software. Most reliable things are, for example, planes. So this plane is a 787, and there's a problem with that one. You have to reboot it after a couple days because of an integer overflow. So after 248 days, which is 2 to the power of 31 100th of a second, you have to reboot the entire plane, otherwise it will fall from the sky. Which is really sad. An epic bug. Land rovers. This is a NASA rover on Mars. When they landed it, it stopped responding. And the reason is that the flash memory that they used was full. So you cannot just walk over to Mars and replace the USB stick. And what they have to do was delete files. And it started working again. Needless to say, it was developed in C++. I bought Jan for the laugh. What could that be?
Oh, is that the 500-mile email issue?
That's the 500-mile email issue. So there's this university that in North Carolina that wanted to send emails, and every time they sent a mail 500 miles further away from their location, it was cancelled. And the reason was speed of light, because the SMTP server was configured in a way that the timeout was 0 because of a change in the configuration. And that meant that it had 0 seconds to be transmitted. But 0 second meant that there was a switch which took 100 milliseconds to do that. Actually 3 milliseconds, sorry, 3 milliseconds. And that's the speed of light. So you can send emails to PenU, but not to, I don't know, MIT, which is sad. And you might say, well, a lot of people, when I tell them that software is broken, they say, yeah, it was all better in the old times. It's a demo of Microsoft's speech recognition back in the day. That worked out really well. You just click it.
Dear Mom, comma. Fix Ant. Delete that. Delete that. Delete that. Select all. I think it's picking up a little bit echo here. Delete. Select all.
Things happen.
Okay.
They happen now, they happen in the past, they also happen in the real world. So this was our office a couple days ago. Someone decided to take a U-turn and maybe hit too hard on the gas, and then a lot of people were happy that because they could collect all this alt beer. Everything is broken more. The fuck? The fuck? Okay, no, sorry, just kidding. So I'm Matthias, I work at Trivago, and I do weird things, mostly website performance and backend, but I'm also active in open source development, and I have a blog, and yeah, I like readable slides, as you can say. This is about software and what's the state of software in 2019 and what you can do to improve it. I would say when it comes to brokenness, there are two factors which are really important. Those are the human and computer side of things, so to say. I thought, is it even necessary to give a talk about broken things if you can just Google everything these days? You can go to Google and search for a solution to a problem. So I was curious on what Google might tell me if I asked how to prevent bugs. Well, it turns out they get some really nice instructions. So you seal up cracks and openings, and you clean up the kitchen, and you dry up damp areas. I'm like, I've been a software developer for 10 years. What's the kitchen about? Like, what's this technical term? And what is outside? What does it mean? Of course, this is for real-world bugs. But I looked up the definition for a similar search, which was how to avoid bugs while programming. And I noticed something. I noticed that the instructions are more or less similar. If you look at the list and you compare, sealing up cracks and openings, maybe that's code reviewing, keep reviewing your own code, or clean up the kitchen. Maybe you want to keep a focus on development, or create a barrier to keep bugs out while you keep writing unit tests. You are writing unit tests, by the way, right? Everyone is writing unit tests on a daily basis, so I'm not going to beginning to regret to invite Jan. We are more or less those people. Drop dead pest control. That's what we are. And I wondered what our responsibility is and what we can do to maybe improve the situation. So as I said, it's hard, but I got the perfect fix for you. On weekend, I was programming and I developed a tool which can solve all the bugs. It's gonna work 100% and it's gonna fix all your problems. It's called the Human Abstraction Layer, or HAL for short. And if you don't get that reference, then I'm getting older, but more or less, there is no silver bullet here. There is no way to build a tool which will work 100% of the time. What you need is a combination of engineering and human factors. Let's focus on the human factors for now. And I want to introduce you to the biggest problem that we have in software development in general when we speak about human interaction. And in my book, this is bias. This is our main problem that we are facing whenever we develop software. You might say bias, okay, bias, it's kind of a thing that people bring up all the time, and maybe it's a very generic term. But let me give you an example of my definition. Let's say you are in Paris in 2008, you and your friend, and you're trying to catch a taxi, any taxi. And for some reason, it's a busy day, so you cannot get a taxi. Then you come home and you have the beautiful idea of creating a ride-sharing app. This is how Uber started. So one guy is saying, hey, wouldn't it be a great idea if we could share rides and get taxis everywhere, because we disrupt taxis? And the developer said, yeah, that's a really cool idea. Let me start coding. And what they come up with is a definition for a ride, which has a car, and a driver, and a rider, and a destination. And that's all cool until the point where your friend goes, you know what? We could stick more than one passenger into one car. And you would be like, that's kind of a cool market opportunity there. And the only thing I have to change is I make riders a vector and I make destinations a vector. Or maybe I have a combination of riders and destinations as a tuple and maybe order them sequentially. And your friend goes like, this is working really well. We're growing like hell. How about adding trucks? And this is the moment where you question your life decisions and you kind of start hating your co-worker, your co-founder. And you go like, well, I can introduce something like a vehicle component. We just have to rewrite the entire backend again. And it's going to cost us ages. And your friend goes, Uber bike. And you're like, sure. We have a driver, but actually it's not a driver anymore because it can also be a rider because there's no bike driver for you. So you drive and you ride yourself and it's all over the place. Imagine the Uber backend at this point. People going haywire and saying like, oh my God. For computer science, that's the worst. So we kind of broke all design principles. All the assumptions that we had in the beginning were wrong. And some assumptions are a form of bias. And you were like, okay, this is kind of the final abstraction, right? This is it. We can cover all cases. And your friend goes, Uber Eats. Assumptions are really powerful. I think one of the main reasons why software is broken is that you can never start with the right assumptions. You will always be wrong, no matter what you do. I will have a couple more examples like that. assumptions, let's keep that in mind, are always wrong. Let's assume you want to build a photo detection app. And you get a bunch of developers into a room and you say, hey, we have to classify images. Easy, right? You take a couple sample images, you produce a machine learning algorithm. Awesome, amazing customer feedback. It's all great. You ship it, and it turns out that you made a mistake. You made a terrible mistake. You made a terrible mistake because I would not classify the top ones as airplanes. No, of course the gorillas. Like literally, the worst thing you can do is misclassifying human beings. That's so disgraceful. That's so embarrassing. But I'm pretty sure when the engineers at Google saw this, they were like, oh my God, we know exactly what happened. And that's bias. They were biased. Why? Because they got a bunch of white male engineers working on machine learning because, well, okay, that's what they had, and then they built this. So there was no diverse team. There was no one saying, wait, in our test set, did we consider non-white people? In our test set, did we consider handicapped people? Is there anything that could go really haywire here? There was just a bunch of engineers starting on a real cool project, and it seemed to somehow work. But this is a horrible, horrible, horrible thing and should not happen, and it's bad user experience. But we get it. It's software. It breaks. Unless it shouldn't. And then people die. It can happen that people die. So this was also a test experiment by Uber. And they had those self-driving cars. And this was the first accident that happened in 2018 that was deadly. A woman, pedestrian, crossed the street, and she did not pay attention. There was a car approaching. It was kind of dawning, and the car recognized her but assumed that she would stop. And there was another assumption that the brake system would work in time. And then there was another assumption that the backup rider, the driver, would be attentive. Turns out that in the investigation they found that this person was looking down, and it could be the person was looking at her phone, but we don't know. And this is also a form of brokenness. This is broken software. Then they got a huge audit. They found a lot of bugs in their code, a lot of misaligned assumptions, a lot of bias. And in the end, they had to stop the entire program. Okay, you might say not every software is life critical. I'm not working on this. I cannot kill people. Well, it starts simple. Any bias in here? What's the bias?
Order.
Middle name, order.
Last name.
Do you have a last name? Do you have a first name? Do you have a name? Well, there's a website about falsehoods programmers believe, and I advise you to read it. It's comedy gold. There's one about names. And there's a guy who works with user interfaces a lot. And he comes up with a lot of things that people assume, especially programmers, about names that are wrong. So the first thing is your assumption that people have exactly one canonical full name. That's not true. In some areas, people have multiple names, depending on the context. You might assume that people's names don't change. If you have a form, you sign up on Amazon, you sign up once, right? That's your name. Well, you can change the gender, you can change the name, you can get married. You might assume that people's names are written in ASCII, because that's the American standard of information interchange. And of course, everyone's using ASCII, unless you have someone from Norway or Germany with umlauts and whatsoever. then ASCII doesn't cover you. Not even UTF-8, not even any encoding, not even one encoding. It can be multiple encodings. People's names do not contain numbers. That's not true. You have, I don't know, Richard III. Okay, I get it. Surely people's names are diverse enough such that no million people share the same name. My system will never have to deal with names from China. Because there, that can happen. Or Korea, or Japan. Okay, but if there's one thing that is true about names, then they are assigned at birth. I mean, maybe not at birth, but like pretty close to birth, right? I mean, all right, within a year or so of birth. 5 years? You're kidding me, right? People have names. So many assumptions on a simple thing that maybe all of us kind of take for granted. But the point is that we have no idea whatsoever what we are doing. We have no freaking clue what all of this is about. No one. If you think that you have a clue what you're doing, that's your bias. Why do I know that? Well, there's another example. And the example is geometry. Geometry, I think everyone went to school, had it in school. What is geometry? Well, if you translate it from ancient Greek, it means measuring the size of Earth. That means you measure the size of Earth once, then you're done. This is geometry. We're done with geometry. Tick. We can move on to the next topic. Well, turns out geometry is a subset of mathematics which has roots into every other area of mathematics, algebra, and so on. And it's about shapes and forms and the nature of surfaces and things that we can see in the real world and what mathematical properties they have. So I looked up the definition, and it's like the branch of mathematics concerned with the properties and relations of points, lines, surfaces, solids, and higher dimensional analogs. If I told someone in ancient Greece that this is really what they're doing, they would say, you are insane. We're just trying to measure the Earth. It's geometry, right? Well, they have a huge history of great mathematicians. Decades, centuries, millennia. What do we have? Computer science, how old is it? 70 years? 200 years? Depending on how you count. Maybe 1,000 years if you account for mathematics, information theory. We are at the very beginning of our journey when it comes to computer science. And I kind of hate the term computer science. Because it's neither computers nor is it science. It's not about computers. It's not a strict science. It's a lot of things. It's multiple things clubbered into one right now because we don't have a proper name for it. Geometry. We said it's computer science. Like, it's the thing with the computer, computer science. Everyone gets it. That's why I like information theory, which is more mathematical and more to the properties of what we're doing here. But it still only covers a small part. Is machine learning a part of computer science? Is data engineering a part of computer science? Are we doing the same thing when we deploy a Jenkins pipeline? Is that computer science? I don't know. You have to judge. You're the judge. My point is, assumptions are unavoidable. We have a mental model of how the computer works. We have an interface with other code that someone else wrote. Dome wrote it. Dome wrote all of the internet you didn't know. UI, UX problems or assumptions. Everyone has a finger to tap your button. Time pressure. We will have plenty of time to do that. Or whoever said, we'll fix it later. It's okay for now. It's just a test. Budget constraints. Can you do it with half the budget? Can you do it with 1/3? So assumptions are unavoidable, bias is unavoidable. And this kind of sums up the first part. And I would like to give you some hints on how to avoid that. Now that we've clarified that there is a problem, I would like to maybe talk about ways to maybe avoid those problems. I came up with a list. It's probably not complete, but I think it covers a bigger part of it. So, accept that mental models are flawed. Whenever you develop something, accept that there is a flaw. And accept that you will make mistakes. Yes, you will make mistakes, not anyone else. You will make mistakes. So how to avoid that would be starting small, iterating, keeping things simple. Even as simple as having others understand what your code means. That's kind of a cool thing. It's kind of a feature. Let external people test. That means if you have a machine learning algorithm, let them test if it works. If you have a UI, UX form, let them test if they can enter their data and your system, your assumptions are correct about the system. And embrace change. You will have to change the system all the time. It's never going to be done. Embrace change. And the second part, I would say, is building a culture around sharing knowledge. To build a common understanding of what you're building here, to do code reviews, to learn to communicate, and to drop your ego. If there's two things that I learned from the last 10 years being a software developer, it would be learn to communicate and drop your ego. Communication is probably the best thing you can do to your career if you are a developer. Not writing any more code, not writing a framework, not doing any sorts of programming. Communication. Like what I'm doing right now. Share your thoughts and let's get this going together. And do drop your ego. If you come to work and some junior dev sits at your desk and works on some code, pair with them, learn from them, just observe. Don't even try to make your assumptions part of their world. Try to avoid your assumptions. And the last thing is build a diverse team. If you only have male, white, fortunate people in your team, then you have a problem. That's the problem that you should solve first as a team, as a manager. Try to have a diverse team of people from different backgrounds. So that's the human side. Let's move over to the technical side. And for the technical side, let's talk about bugs. Like real bugs. Bugs that affect us all. For example, this one. You might not have heard of it, Poodle, SSL3 vulnerability. Not too long ago, a horrible, horrible thing. It broke all of SSL3. Or Heartbleed. Or Ghost, which was a glibc problem. Heartbeat was in OpenSSL. What else? Yeah. Channel remote code execution. Then the bash bug, shell shock. Those are all things that are in critical software that we use every single day. And it's broken. It's just horribly, horribly broken. And a lot of people ask me, like, how do we end up with so much broken legacy code? Cannot everyone just write working code? Is it so hard? Is it really this tricky to get the simplest thing done? Like if you have something critical like OpenSSL, that should never break. This is what the entire internet relies on. But it's hard. Let me give you an example. Maybe in school you wrote a program like that. And this is horrible. Don't ever do that. Printing a count. This is broken code. Never ship that code because the count is not initialized. What will C do with that code? Well, you might be a reasonable developer. You might say, well, it might crash, right? It might not even compile. That would be the most sensible thing to do. Or you might say, wait, I heard something about C being really awkward about that. probably it will initialize it to 0. And it prints 0 even though I haven't initialized it to any value. Or you might say, nah, wait, nah. I remember from school. It prints the random value that was there at this memory location that just happened to be there at this point in time. Well, it might. It might do any of that, or all of them. Because the problem is that this is undefined behavior. It's not specified what the compiler will be doing in this case. It can do anything. Okay, you might say, wait, I always initialize my variables, right? So here's another example. This time we initialize the count. We set it to 0. And then we just add up some numbers. Well, that's terrible. Never do that. Never add up numbers. Because this is really, really broken. Because it's undefined behavior. What is max? It could work, but it's an integer. Could be 32 bits, could be 64 bits, but in the end it will overflow. And overflow is, you guessed it, undefined behavior. So the main problem is that the compiler thinks very highly of you. It assumes that you are smart. And that's why code breaks all the time. And that's kind of a real problem. There was an analysis in 2007 about code bugs in open source. They more or less took all of GitHub and they ran it through some code checker. And they found 495,000 problems with exception handling or error handling, 11,000 deadlocks, and that's all there in GitHub. And that was in 2007. And you might say, how do we fix that? Well, we start with a compiler that does not think very highly of you. Something like a modern version of C or C++ that we could use for our base core of the infrastructure. There's a lot of languages like that, and modern languages can maybe prevent some of those bugs. I'm a member of the Rust community, and in reality this is a secret Rust talk to get you all into writing Rust, but in reality I just want to quickly touch on this language because I think it's kind of interesting. So it's a project that was funded by Mozilla, and the first version was in 2010. By now we reached version 138. And what does it do? It's kind of a safer C for some people, or maybe a faster Ruby, somewhere in between. So it has built-in memory safety. Every memory in your code is always safe. There can be no memory leaks. Yes, that's true. It has no undefined behavior. It's all specified. It has fearless concurrency. That means it runs without any mutex problems, any deadlocks, any race conditions. It just cannot happen. It has very high-level language concepts, so it feels like a high-level language, even though it's kind of low-level. It's easily embeddable into existing projects. It has strong compiler checks. Here's an example. That's the same code. We have a count, and we want to print it, and the compiler says, use of possibly uninitialized count. Okay. We prevented a bug at runtime. That means the compiler saved us. Or our other code snippet, where we want to iterate over numbers and sum them up. Well, it attempted to add with overflow at runtime. Okay, fair enough, but at least it crashes and it does not continue working. And with that, you can prevent a lot of those error cases. Maybe not logical bugs, but everything that has to do with memory usage. The way it does it is with some kind of ownership. Basically, there can only be one owner of your data at any point in time. And the one that owns it cleans it up. And with this, you can avoid all those problems. It was kind of magical when they first discovered it. But at some point, something will go wrong, even with Rust. And then you need another thing, which is very often overlooked, which is isolation. And that's why Docker is so popular, actually. Not because it's platform, I don't know, compatible with multiple platforms. No, because it provides some certain level of isolation. And this can help you make your project better. But the problem with Docker is it's actually not really cross-platform. It runs on Linux mostly, with containers, with C groups. But on the web, for example, you cannot use Docker. Or on Mac OS, it's kind of painful. On Windows, same thing. But the web is our application development platform these days, our application delivery platform. We kind of stopped counting here in 2014, but you can see the number of websites going up exponentially. And for that, if we take the web as an application delivery platform, which it is by definition, we need something like Docker, but for the web. And this is where WebAssembly can come in. WebAssembly is another open standard. It's language independent, so you can use WebAssembly with every language. It's a safe sandbox for your code. It's super fast. It works everywhere, so in the browser and outside. And this is really, really important for the future of application development. I just wanted to raise awareness. I will not show you any code examples, but that's something to look into. I will give another talk about that in Bristol in a couple of weeks, and there will probably be a recording. So watch out for that. But the main thing is you can now write safe things in anything other than JavaScript for the web. So you can use your Go application, put it on the web, it will just run, it will just work. You have some PHP script, you can use WebAssembly to run it. And it's going to run in a safe, isolated environment across platforms, like more than what Docker provides. It's way more, all platforms. And I'm not the only one saying this. In fact, the Docker developer himself, the main Docker developer, Solomon Hykes, he said, if WASM and WASI existed in 2008, we wouldn't have needed to create Docker. That's how important it is. WebAssembly on the server is the future of computing. A standardized system interface was the missing link. Let's hope WASI is up to the task. That comes from the founder of Docker. It's that big of a thing. So look into WebAssembly. But what if you want to change something right now? Because this is kind of the future, maybe-ish. But what if you want to do something right now to improve your code? Well, there's a lot of linters, a lot of analysis tools. This is a project of mine where I collect linters for different programming languages. And there's probably a linter for your language in there. If not, then probably you should send me a pull request. But you look at the list of things that you can use for static analysis of your code. And you can change it right now with your code in your CI pipeline today. That's kind of cool. So to sum that part up, let me give you some tool tips. I wanted to add Clippy here, but I thought it was a bit too cheeky. So use safer languages, Rust, Ada, Cork, Idris. Those are up and coming. And it's not too far in the future that you can use those and start experimenting with them. Use sandboxes like Docker and WASM if things go wrong. You still write tests, right? You write tests. We are sure that everyone in this room writes tests. Use type systems maybe for your more critical code. You don't have to use type systems everywhere, but they can help you finding problems. And for God's sake, use an IDE. It's 2019. Don't write with Notepad. Get yourself a proper IDE. Use common libraries. Use linters. And by all means, if there's only one thing you have to remember from this entire presentation, don't roll your own crypto. So the final part is the fun part. And I guess what I want to show you is some parts of broken things that are really cool and that are fun. In my opinion, broken things are an opportunity for creativity. And a lot of things that we have today are only possible because some systems were broken. Let me give you an example. Maybe you have heard of a little Italian plumber, and you played some games in your youth. Now, you all know this game, Super Mario 64, okay? Oops. That only works with clicking, I guess. You come out of your pipe, and then you start running to the castle, and off you go. Well, turns out this... What the fuck? Turns out this game is inherently broken. It's broken beyond repair. You can play through this game in 4 minutes and like 30 seconds or so. That was a tool assisted speedrun. That means there is a tool in the background that was programmed to have inputs. And this is why it's so fast. But the world record right now is somewhere around 6 minutes and 27 seconds for the entirety of Super Mario 64. I'm a fan of speedruns. This was the any percent category tool assisted speedrun, but there's the any percent for humans. And if you see the graph over time, it's astonishing what you can achieve with broken software and how broken things were in the past, how broken games were in the past. So this was the past, right? Modern games are not broken anymore. Well, let's look at Zelda, Breath of the Wild. No? Can I show you? So it starts off, what? So we hump a wall. What the hell is this guy doing here? So he clips through the wall, and then he runs through endless white up the mountains naked, arriving at this sanctuary. You can see 2 minutes 50 in, some kind of glitch hack again, clipping through this wall, going to the first sanctuary, and then this here, which brings you all the way to the castle. And we are 15 minutes in, so the entire run right now is 28 minutes and 59. And a lot of that time is spent in the castle and jump screens and so on. And I think that's fascinating. I don't think there's anything wrong with that. I think this is great. When I was a kid, I played Super Mario Kart 64, and I kind of played it competitively. So at some point, 1 year after it was released, I held the European world record for Yoshi's Valley. And I was very proud because I was the first one below 2 minutes. Well, thank you very much. Thank you very much. But I wanted to show you, because I have the backup, okay? I have a backup slide for that. Yeah, I cannot show you. It's kind of sensitive. No. Wait. Do you want to see it? Do you want to see it? Okay. Okay. Went a bit like this. This is Abney playing, which is the current record holder for both categories, playing without glitches and playing with glitches. He's much faster than me, so 1 minute 42, which is kind of astonishing. I think this is very close to the world record these days. Actually, I think he's 3rd place at the moment. And this is how I used to remember this game, and this is how I played it. I don't have recording of mine. But in reality, this happened. When I saw this the first time, I was really sad. Round 2 glitches through the entire lap. This is how you play Super Mario Kart 64 today. When I found that 5 years later, I had to send this email to my brother and called him right away. I was like, they stole our youth. And yeah, I think by now it's hilarious. There's other things you can do. For example, jailbreaking your home devices like consoles. This is running Ubuntu on a Nintendo Switch. More or less all the consoles are broken these days, and that's great because first off, you can run your own custom hardware, software, and second, you can still run the old games. And if those were not jailbroken, you would not be able to run the games anymore because not even Nintendo has copies of those anymore, sadly. So maybe to wrap it up, I want to foster your creativity. Just because things are broken doesn't mean you cannot fix them. Just because things are broken doesn't mean that's bad. There's always ways to exploit that, to be creative. And this is what hacking is about. So foster the hacker culture. And do it like Simona Gertz, who's a YouTuber. And she does things with robots. I think I want to give it some second.
Machines, and I've done things like cutting hair with drones. To a machine that helps me wake up in the morning. Oh! To this machine that helps me chop vegetables.
Check her out on YouTube. Accept failure, beware of bias, embrace change, invest in tooling, and don't be a jerk. Thank you very much.